methodology in order to accurately predict the shutdown dates. So the first stage of our study is to intensive study of the system and representative parameters to do this calculation. Firstly, the team needed to decide on HTC or conventional way, depending on temperature only. So we choose that we are going to go with HTC since it will give us more accurate results. Then we need to identify the correct parameters that we needed to do for our calculation. Sometimes, for example, we have this inlet to this heat exchanger with different branches, but there is no temperature indicator for number of branches. So we need to come up with a tool that will make it easier to give indication of these measurements. The third thing is to overcome difficulties faced at this stage. Example of such is, as we said, flow rates or temperature of stream in case of branch line, instrumentation absence, and multi-phase streams. That overcome by intensive study of the system to derive measurement tool. We go back to the BNID detailed study where we can find our parameter that we can use to do this calculation, along with going to the field, tracing the line, making sure they are the same as in the BNID. Variation of HTC with variation of flow rates to the heat exchanger. We needed to have this collection which will give us more accurate HTC which represent the system. Account for two phases as it greatly impacted both heat duty and overall long mean temperature difference. That then by having this differential equation which will split the total stream into vapor and into liquid, then we can do the calculation easier. Overall heat transfer area, this can be done by having this level and how it impacts on the overall heat transfer area. Finally, specific heat capacity and latent heat. By understanding the system, the component that we have, sometimes we have 25 different components, system condition is different, so we needed to go with the simulation. Second step, and so this is what I talked about, the level percentage and how it indicates the total heat transfer area. Second step is data extraction for system parameters, that done by using Quantum, which is data collecting tool. And these data that we extract from the plant are very important in order to do the calculation and will give us the daily to daily basis, the HTC change. Third step, prediction of future behavior. The challenge is that HTC is not linear, so it doesn't decrease linearly. It depends on the plant performance, plant status. So what we needed at that time, we needed to go for regression method. Since Excel doesn't develop this, we needed to go with software called Minitab. From Minitab, we used the regression method to use it for Excel. Then we can build our model which will give us reasonable, accurate shutdown dates. Fourth step is performance tuning. We did study for a number of cycles and we gained 3 more benefits. The first one is we know the limitation of our system. We know the area where we cannot operate. Also, from cycle to cycle, we improved the accuracy of this tool. Beside these 2 advantages, we have one advantage that we can know by changing some of the operational philosophy the change of the HTC. If we change temperature, if we change the amount of ethylene to reactor or amount of solvent, what will be the impact on the HTC? So this is what we got out of this innovative tool. This is for a number of cycles. So this is only modified graph which will give us the indication of what we are talking about. So HTC will drop from time to time, and we can, by having this tool, understand the performance of the heat exchanger. We can also predict the shutdown dates. Moving now to the results. So the tool was firstly implemented in 2011. It enabled us to understand the behavior of this heat exchanger, and also to take necessary corrective actions to predict shutdown interval and major saving and better communication with our customer around the world. So in 2011, the number of cleaning shutdown was 4. In 2013, the number of cleaning shutdown was 2. So that means there is a reduction of 50% of cleaning shutdowns. In conclusion, so implementation of this such innovative tool will give us a directional judgment of this heat exchanger performance. We can take action in advance, what we can do, what we can change in our process in order to solve these issues related to decrease in HTC. So as we said, number of cleaning shutdown reduced by 50% in between 2011 and 2013. 16 million Saudi riyal saving, and major contribution was from this tool. And finally, trust built between Sabik and its customers around the world. Thank you all for paying attention to our presentation, and me and my colleagues are happy to handle any of your questions that you may have.
Thank you, Engineer Nabeel. Now is the question time.
Manufacturer, thank you Nabeel for this great and innovative method of predicting the performance of heat exchanger. My question, and also mixing process with mathematics. My question, can we utilize this one for any type of heat exchanger is subjected to a fouling process? So we can take this model, we can use it in any like styrene heat exchangers or any other heat exchangers.
Thank you very much for your question. I believe yes, we can do if we have same nature of this process. We can utilize it to indicate the heat exchanger performance reduction, the heat transfer coefficient. So in our case, our indication of cleaning, that means we have reduction in heat transfer coefficient. When we reach to certain limit, then we need to go for cleaning of this heat exchanger. So I believe if this is applicable to other process, maybe they can utilize this.
And what your heat transfer coefficient, you use that to predict your shutdown. What level did you decide to shut down at? You had your curves dropping and you had your graph. What level did you choose? How did you choose it?
We choose when we reach to a certain value or a certain range, then we need to go for this cleaning shutdown. This is
that was based on experience?
Yes, absolutely.
What's the method strategy for the exchange?
What?
The method strategy. The method strategy. According to the equation that you see, the equation means that you do a periodic maintenance of the exchange.
Yes.
Why didn't you go with a condition-based maintenance? When you have the industry go to certain limit, then you shut down and you clean and you start picking back up.
This is what we are doing when we reach to a certain condition of this heat exchanger. We are going for cleaning shutdown. But since
So the question is it calculated or is it from a sensor or something?
no, calculated.
A value that
You can indicate from sensor.
yes.
No, it is calculated.
like to thank you, dear Nabeel, for this impressive presentation. And STM11 would like to award you a certificate with small gift.